Okay. So today we're going to talk about scientific notation. The main purpose for scientific notation is to be able to easily work with very large numbers and very small numbers. So we're going to practice that. One of the rules of scientific notation, for example, if you have a number like 425 million, that number can be written with a power of 10, and it would be 4.25 times 10 to the 8. One of the rules with scientific notation is you only have one number to the left of the decimal. So if you do some problems with scientific notation and you end up with an answer that has 2 or 3 numbers to the left of the decimal, you're going to have to tweak it. Okay? So if we were going to take a number, for example, like 5.34 times 10 to the 4, that's already in scientific notation because there's only one number to the left of the decimal, and it's being multiplied to a power of 10. If we want to put that in standard form instead of scientific notation, we would move the decimal the number of places of the power. Okay? And we're going to move it to the right. So it's going to go 1, 2, 3, 4. 53,400. Which, if you were to multiply 4.34 times 10,000, which is 10 to the 4th, you get 53,400. If you had a really small number, like 3.27 times 10 to the negative 3, this negative exponent is really, remember when we talked about exponents before, that power of 10 should go in the denominator and become a positive exponent, right? So this is the same as 3.27 times 1 over 10 to the 3rd power, right? We talked about that last week. So when we are dividing by a power of 10, we're going to do the opposite of what we did when we were multiplying by a power of 10. We're going to move the decimal to the left. So this is going to go to the left 3 places. 1, 2, 3. Okay? All right, so now we're going to go to page 60 in the textbook, and we're going to talk about multiplying, dividing, adding, and subtracting scientific notation. So if we have two numbers, 7.2 times 10 cubed times 1.6 times 10 to the 4th. When you multiply those, remember last week we talked about multiplying powers, and if you're multiplying straight across, you're going to add the exponents. So this part is easy right here, right? That's 10 to the 7th. But we've got to also multiply the 7.2 and the 1.6. And we get 11.52. Well, that's not scientific notation because the rule is you can only have one number to the left of the decimal. So we've got to move this way, and when we do that, your exponent on your power of 10 is going to get bigger. So when you move it to the left, the exponent gets bigger. So we're going to get 1.152 times 10 to the 8th. Now we'll try another one. try 2.63 times 10 to the 4 times 1.2 times 10 to the negative 3. Well, if we follow our rule of adding exponents with like bases, we're going to have 4 plus a negative 3, which is 10 to the 1. And we do the multiplication of 2.63 and 1.2. One, two, three, 3.156. Okay, so that's multiplying exponents, scientific notation. Now we're going to look at dividing. Well, if we have a number 7 times 10 to the 9 divided by 3 times 10 to the 8, just like we learned with the law of exponents that when you multiply powers with the same base, you add the exponents. Here we're going to subtract. So 9 minus 8 is 10 to the 1. And then 7 divided by 3. Oops, 3. And so on. So it's going to be 2.3. So approximately 2.3 times 10 to the 1. Okay, so with adding and subtracting scientific notation problems, you have to tweak it a little bit sometimes to be able to do it. So we've got example 6.89 times 10 to the 4 plus 9.24 times 10 to the 5. Well, in order to add this, you're going to have the same power of 10. So we're going to have to change either the 9.24 or the 6.89. Well, if I wanted to make this 10 to the 4th a 5, I could move the decimal that way and make it a 5. So let's try that. 0.689 times 10 to the 5 plus 9.24 times 10 to the 5. And we keep the power of 10 and add the numbers. And we're done. Now, if you had chosen to change the 9.24 to be a power of 4 and move the decimal to the right, you would have ended up with the same answer. But you may have had to put it in scientific notation once you had your answer, because it might have been 2 numbers to the left of the decimal, and remember, you can only have 1. And if we're going to subtract, let's try 7.83 times 10 to the 8 minus 11,610,000. First thing we want to do is take advantage of scientific notation and put 11,610,000 into scientific notation. Now I'm going to put it with a power of 8, because this is already a power of 8. So I have 7.83 times 10 to the 8 minus 1, 2, 3, 6, 7, 8. 0.1161 times 10 to the 8. And I'm going to get a 10 to the 8. 0 minus 1 is 9. 12 minus 6 is 6. 7 minus 1 is 6. Oh, I lost my place here. .7139 times 10 to the 8. And I don't have to move my decimal because it's already in proper scientific notation. All right, so here's a couple of practice problems of adding and subtracting. We have 8.41 times 10 to the 3 plus 9.71 times 10 to the 4. Okay? I'm going to have to move the decimal over on one of them. And so I'm going to make 8.41 times 10 to the 4. So I'm going to do 0.841 times 10 to the 4 plus 9.71 times 10 to the 4. And I'm going to get 10.551 times 10 to the 4. The problem with that is that's not scientific notation because I have to move it over 1. So I'm going to move this over 1 because I can only have one number to the left of the decimal. And I'm going to get 1.0551 times 10 to the 5. Okay, so let's try 1.263 times 10 to the 9 minus 1.525 times 10 to the 7. Okay. So I'm going to go ahead and, since I don't want to deal with negative numbers, I'm going to move this over 2 places and decrease the power of 10. So I'll get 126.3 times 10 to the 7 minus minus 1.525 times 10 to the 7 But then again, I have 3 numbers to the left of the decimal, and I'm going to need to move it over so that I don't have 3 numbers. So I'm going to move it this way, which is going to grow my power of 10 to 10 to the 9. Okay? All right, so now we're going to try 6.3 times 10 to the 5 plus 2,700,000. So we're going to go ahead and I'm going to put this, to make it the same power of 10, it'll be 6.3 times 10 to the 5 plus see, 1, 2, 3, 4, 5. 27 times 10 to the 5. So when I add that, I get 27 plus 6.3 and it's both to the 5th power 5, 10 to the 5. And I add and because that's not scientific notation, I'm going to have to move it over and get 3.33 times 10 to the 6.